Our presentation is divided into two parts: Self-Adaptive Software Development Toolkit and Self-Adaptive Software Operation Support Platform. The first part is Self-Adaptive Software Development Toolkit, which includes four tools. The first tool is Architecture Modeling Tool. Create a new architecture description file, cnntest.xml. Create a structure. Under the structure, you can create components: function agent, code agent, encapsulated unit. For example, you can create a code agent named news code. It encapsulates the load balancer. And then you can create an encapsulated unit named the load balancer. cnn.xml is our architecture description file that we built for the web application cnn.com. This structure contains a code agent named news code, four function agent components: the client agent, server 1, server 2, and server 3, and five encapsulated units, in which JMeter encapsulated into the client agent. Server 1, server 2, server 3 are servers encapsulated into the function agent server 1, server 2, and server 3. The generated XML file records about agent and encapsulated unit information as XML nodes. Every component node has two attributes, ID and name. In the future, we will add more properties to these nodes, including the IP address, port, the J container name, and etc. The second tool is Agent Collaboration Graphical Modeling Tool, which models the collaboration process among services and the definition process of a composite service. The first function of the tool is to model the collaboration process among services. First, new a blank document, then draw the collaboration process. On the left is element box, and the right is drawing area. We choose the begin element as the beginning of the process, and choose composite process, choice atomic process, drawing and end to draw the process. Now, this is the completed collaboration process. At last, we save the collaboration process file as a XML file. The second function is to model the definition process of a composite service. Similar with the first function, we first new a blank document and draw the definition process of composite service, then get the completed definition process and save it as a XML file. The third tool is Intelligent Component Development Tool, which is used to generate the code framework of an agent class. The first step is to enter the tool. The second step is to new a manager agent class, whose name is News Manager. The third step is to add the service definition file of News Service, which is produced by Agent Collaboration Graphical Modeling Tool. The fourth step is to add behaviors for News Manager, and the behaviors include monitor, analyze, and plan. The fifth step is to add events and the corresponding rules for News Manager. Click the Finish button and we can get the code framework of News Manager agent. These are the code of events and the code of rules respectively, and this is the code of behaviors. The red dashed line marks the errors, which reminds the user to modify the code to meet their requirement. The fourth tool is the Adaptive Library Management Tool, which can manage different libraries and generate codes to make up for the omission of Intelligent Component Development Tool. The first step is to enter the tool. The second step is to manage libraries and generate the required code based on the code generated by Intelligent Component Tool. The behavior view, the role view, the service view, and the rule view can manage the behavior, the role, the service, and the rule respectively. Take the behavior view as an example. Click Add button and add a new behavior with the behavior name and the behavior parent. The behavior list will show the new behaviors. Then select a behavior and click Copy button to add the code of behavior to the specific area. By dragging a behavior, we can also add the code of behavior to the specific area. The operation of role view, service view, and rule view are similar to the operation of behavior view. Presentation Part 2: Self-Adaptive Software Operation Support Platform. Step 1: Start the JIT platform and our multi-agent system. Step 2: Start the server of self-adaptive software running support platform. Step 3: Enter the user interface of our running support platform. Step 4: The user submits the collaboration process definition file between agents. Step 5: Our platform resolves and executes the collaboration process definition file between agents. Step 6: Our platform displays the collaboration between the agents. At the same time, the ZNN load balancer and two ZNN application servers were started. Step 7: We try to visit the current ZNN news site. You can see that ZNN is currently offering high-fidelity mode news services. Now, we switch to another computer. Start JMeter at another computer, simulating multi-user accessing to the ZNN website concurrently. Firstly, we simulate a smaller concurrency. Start 200 threads concurrent access ZNN website. The client agent reads the JMeter records and computes the real-time average response time, and the console outputs the time. After running for a while, we simulate high concurrency, starting another 200 threads and setting the start time 4 seconds. You can see that the response time increases. Response time exceeds the threshold of 7,000 milliseconds. The console outputs the adaptive decision-making information. Now we switch back to the computer node where the support platform is located. We can see that the ZNN application server is dynamically started during the system adaptation process. We can see that the collaboration between agents of our platform is dynamically refreshing, and we can see that the number of servers in the ZNN server cluster has increased from 2 to 3. Our platform enables real-time monitoring of state of ZNN system from its inception to the present. These system states include content fidelity, number of servers, and response time. The three graphs show us that the adaptive software system we developed can adjust the number of servers in the system and the content fidelity of news service based on the changes of response time. Our platform supports dynamic changes in users' needs. For example, a ZNN system administrator can manually switch the content fidelity of the ZNN news. For example, he can switch from the current plain text mode to the low fidelity mode. After switching the service model according to the user's needs, we try to visit the ZNN news site. We can see that the current service model of ZNN news site have switched to the low fidelity mode. Our platform can show its adaptive decision information in the process of running the ZNN system. This adaptive decision information includes adaptive time, events to the process, adaptive action taken, and so on.